If you're interested in the subject, you might move where you can see the telly, because there's going to be a few things on there tonight. I'm also going to talk at the end about some different resources and websites and apps and things that you can use to help you with space weather and propagation, but don't go in a frenzy trying to write them all down and remember them, because I've already sent all the information to Jim and he's going to put it on the website. So everything that you see in here tonight, you'll be able to go to the club website at your leisure and look up all the links and all the stuff, and also a copy of the slides are on there and a link to a really good video. Because I better start with that. I'm no expert on space weather and I'm no expert on propagation either. But I got to the point where I was looking at these figures and the numbers that they give you and all this stuff, you know, SFI and KP, and I'm like, they come up with these predictions as to which bands are going to be open and which bands are not going to be open. How do they do this? How do they get to how the bands are going to be from the numbers? So I decided I was going to learn about it and just find out so I could understand it for my own benefit. So I'm no solar physicist, so somebody's probably going to ask me some smart aleck question that I cannot answer, and that's why. But what I'm going to tell you is how you can look at the numbers, roughly how space weather affects propagation and what the key things are, and you'll be able to actually look at that and make some sense of it, hopefully, and give you some resources that you can use as well. So, question we always get asked is, why are the bands so rubbish? The bands are dead. Dead, I tell you, there's nobody on. But that's not always true. I mean, sometimes the bands are dead, but they don't stay dead. They come on again. And sometimes you can't work like ultimate DX halfway around the planet. But the thing is, space weather is like weather. It comes and goes. So I'd say, you know, like he says there, just go and try calling CQ. All you can do is work a few French and Italian stations. That's all that the HF system's going to support on that day. But that's what you can do. You know, hey, it's a hobby. It's supposed to be fun. So let's not get obsessed about whether the bands are shut or whatever. Little bit of space weather information then. We mentioned space weather because this is a new term that's been coined fairly recently. And it's basically just looking at the effects of solar activity on what's happening on planet Earth. It's dead simple. So it's all to do with what the sun's doing. Governments are now taking it seriously, and you'll see why in a little while, ours amongst others. It affects things like satellite operations. There's a lot of satellites up there, there's GPS and various other things. And when the sun's not behaving itself, it can affect those satellites. You can get like static charges building up on them. Sometimes they have to move them. Sometimes the comms links to them don't work and weird things can happen. It definitely affects radio propagation. For those of you who don't like HF, it also affects VHF and UHF to a certain extent. It definitely affects things like aviation, communications with aircraft. GPS can be hammered by adverse effects in solar weather. So they want to know about that kind of thing. Things on the ground can get hammered. Internet links can suffer. Sensitive pieces of equipment can suffer. Power grids can suffer. You can get surges and things like that. And if it's not the actual power transmission kit itself, the kit that they control it with can get clobbered by things happening in space. And also manned space flight, of course. People up on the ISS or other astronauts that NASA or others are sending up. You know, if the space weather is bad, it's a question of like, how do you want your astronauts, regular or extra crispy? So they're very concerned about knowing what's going on up there in the atmosphere and beyond. So as we said, solar effects. It all starts with the sun. Oh, not that sun, sorry. That one. So it all starts with the sun. The sun, of course, is the source of energy that supplies everything that we enjoy. Without it shining away up there, even though in Britain you can hardly see the thing shining, trust me, it really is shining beyond the clouds and everything. And without it, life on planet Earth basically doesn't exist. And we also don't have a hobby. So what's going on with the sun? Well, the first thing to know about the sun in terms of solar weather is the solar wind. which is basically the sun shining. You can experience the solar wind, you probably did today if you're outside at all. If you stood in the sun and felt the heat, you're feeling the radiation that's pouring out of the sun. You're only feeling it in one particular band, which is the infrared, but you're also seeing it in the visible spectrum. But there's all sorts of other stuff coming out of the sun that we don't see, charged particles and magnetic fields and radio emissions and emissions at other different wavelengths and things.
Alan,
Yeah.
Alan, you just said right, we feel it.
We do.
Now then, but how long does it take from the sun to when we feel it?
8 minutes.
It's not going to be spontaneous.
It's not spontaneous.
8 minutes.
About 8 minutes-ish.
Yeah.
8 minutes.
Yeah.
Hell of a distance.
So you can look it up. I told you somebody was going to ask me. That's off into the realms of stuff I don't really need to know for what I'm going to talk to you about tonight. But yeah, it does take a finite amount of time, and other things take longer, as we will see.
8 minutes 52 seconds.
Perfect. Thank you. There you go. So yeah, this solar wind is coming out from the sun, and it's going in all directions. It's going all over the solar system. A constant stream of energy coming out from the sun. Some of it, of course, is hitting the Earth, and the Earth has a magnetic field. Here's another nice coincidence. Without the Earth's magnetic field, we'd all be extra crispy, because the magnetic field is acting like, you know, you've seen on like Star Trek and all these other programs. All the spaceships always have a deflector shield. Well, the Earth's magnetic field is the Earth's deflector shield. So all this solar energy hits that, the magnetic field lines kind of funnel it, and you get this squashed effect. You know, kind of it bunches the field up in front, it stretches it out in a tail behind. So all the charged particles and stuff that's coming out of the sun gets caught by the magnetic field lines. Remember your basic physics, something charged and a magnetic field, there's an interaction there. So they kind of travel along the lines of magnetic field, and they gather over the poles, which is why you see the northern lights and the southern lights, the aurora. It's the energy gathering there in the ionosphere, ionizing the atmosphere and causing the glow. And also, it ionizes the ionosphere that we use. So that's where your reflective layers come from in the atmosphere. That's why shortwave radio will bounce off it. That's why we can work and use HF. That's why we have amateur radio. So it's very important, and obviously we want some stability in that, but how good that is and how big an effect that is, we can study. And this brings us on to the first thing. How much is coming out of the sun? That's measured by the thing called a solar flux, or SF or SFI, you'll see that registered as. You can look that up. Here's a graph from 1950 up to 1995. You'll see there's different levels of solar flux there. Less than 100, the sun's pretty quiet, nothing much is happening. About 150, the sun's active. Over 200, there's some serious stuff going on. Basically, the higher the solar flux, the more energy is pouring out of the sun, the more active the sun is, which means the more energy there is in the ionosphere, which means the better the ionosphere works, and generally the better HF propagation is. So that's basically the interaction there. You'll see this thing MUF, maximum usable frequency. You can look that up, you can find that. Basically, I've not really given you that as a primary indicator because it depends on the solar flux. If the solar flux is very low, the sun's kind of a bit half-hearted about shining on us with all its energy, then you'll find out the ionosphere is not as ionized as it normally would be, which means your maximum usable frequency isn't as high as it would be. The lower bands will be open, 80 meters, 40 meters, you might work a few things on 20, but 15 and 10 are probably going to be rubbish. You get more energy coming out of the sun, a higher solar flux, then there's more charge in the ionosphere, those upper bands open up, so the maximum usable frequency will be higher. So it's basically just a reflection of what the solar flux is doing. So SF or SFI, that's the number one thing to remember. That's one of your indicators. And you'll see that it goes in cycles. This, of course, is the famous sunspot cycle. Every 11 years, the sun has a peak, then it goes down again, and it goes up again. That's why HF conditions and the possibility to work in DX varies with that cycle. At the moment, we're right at basically somewhere around the peak of cycle 25. So things at the moment are about as hot as they're going to be. But as you'll see, that's not necessarily all good news. But it'll settle down a bit, it'll tail off, and then it'll come back up again. It always does, don't worry about it. Most of us here are young enough that we've at least got one more solar cycle to look forward to before we QSY permanently. Yeah. So this solar energy, the solar flux, is linked to the sunspots on the sun. Basically, the sun just shines, but where you get sunspots, you get more energy coming out. So the more sunspots there are, the higher the sun's output will be. Basically, they don't entirely know what sunspots are, but there's a lot of study going on at the moment on them. And it's kind of an area of the sun that is far more active than all the rest of the sun. What they think is happening is like it's when you've got a pan of water or something and you're boiling it on the stove, bubbles generate and they come up and they pop. That's kind of like a sunspot. You know, the energy's coming up from goodness knows where in the middle of the sun, and it comes up to the surface and it pops. With the sunspot, you also get a big magnetic field and an electric field and this energy coming out as well. And as we'll see, that can give rise to various things. But the solar flux is linked to the sunspot number. The more sunspots on the sun, the higher the solar flux is generally, and that's again, that cycle. At the moment, we are well, we're not here because that says June 2023. It's the latest graph I could find. It's now August. It's going up higher than the prediction. So maybe the peak of this cycle is going to be coming earlier, or maybe it's going to go a lot further up than anybody ever expected. We just don't know. But so the sunspot number is another index that you'll see, you can look up, and it gives you an indication of how active the sun is at any particular time. They have satellites and stuff and take pictures of the sun. There's people who do this every single day and count the sunspots so that you can have that number if you choose to look it up. So there you go. If you want a nice job, be a sunspot counter. Sunspots also give rise to various anomalies though. We can get the solar flare, which is a sudden intense burst of energy being released from a sunspot. Again, what they think happens is as the magnetic fields and everything rise out of the sunspot, there's charged particles trying to go around those magnetic fields. They end up twisting the magnetic field and it gets kind of cranked and cranked and cranked and twisted around itself like a rubber band. And eventually it all goes twang and lots of energy gets released. So a solar flare is a sudden intense burst of energy being released from the sun's surface. That's all very well, very interesting, but what happens when it hits the Earth? Well, you get this eruption, you get millions of tons of super hot gas containing charged particles, flies across, and if the sunspot eruption on the sun happens to be in line with where the Earth is right now, and it hits us, because obviously the sun can go off in every direction and does, but if we happen to be in the firing line, then we get hit by all that extra radiation, and that of course will perturb the ionosphere somewhat largely. Again, the magnetic field gets hit, it gets distorted. Imagine a shock wave coming along, belting onto the front of that. There's a big sort of reverberation goes on. It rings the Earth's magnetic field like a bell. You get extra charged particles being flooded around to the poles. You get more aurora. You'll get more disruption in the atmosphere. This is kind of why when you get a solar flare or something like that, the bands will die. Initially, what you get is like an X-ray and radio wave burst from the sun. That's how they know it started. That will cause an immediate sort of loss of high-frequency communications. It'll recover, and then a little bit later, the shock wave will arrive, which will do it again by belting the magnetic field. Then it will recover again, and then the charged particles will arrive, which will do it again. So you kind of get this crunch, crunch, crunch effect every time we have a solar flare, and it can, depending on the intensity, nobble your HF communications, which is why sometimes you turn on your radio and you go, the bands are dead. Why are the bands dead? There's probably been a solar flare. And I'll tell you how to know when there's been a solar flare in the resources at the end. So you'll be able to look on your phone or whatever and go, ha, now I know why. I'll go and make a cup of tea and come back in half a day and try again. Because these effects are fairly short-lived, usually. If a solar flare wasn't bad enough, then we get the coronal mass ejection, which is a solar flare on steroids, where actually the sun does such a big belch, if you like, that a whole piece of sun breaks off and shoots out into space. So it's literally what it says, it's a coronal mass ejection. And if the Earth's in the firing line for that, then look out, because it's like a solar flare but much more intense, and the effects are much more intense. What basically can happen with a solar flare, and especially with a CME, is that we get a thing called the geomagnetic storm, which is basically, as I said, all this energy belts the Earth's magnetic field and rings it like a bell, disrupts the ionosphere, HF communication falls off the wagon, all this stuff's going on. We get big auroras, we get strange magnetic effects at ground level. Things can be quite bad. These can be quite, range from fairly mild to ridiculously intense. As we will see, they rate geomagnetic storms on a scale of 1 to 5. There's your level. Would anybody like to guess what the recent aurora that we had was? Do you know what level it was?
3.
That was a G4.
In March.
Yeah, that was a G4. And we saw the northern lights, we saw them here. People down south on the south coast saw the northern lights, which is far more energy in the ionosphere than there normally is. Because normally you've got to go to Norway or Iceland or something to reliably see those things. We were looking at them here. Some people in France saw the things. So that was an indication of how much extra energy came in. And that wasn't just one solar flare, that was a series of 3, all of which hit the Earth one after another. So this can be kind of serious. Just a few bits of history. The big one, the mother of all disruptions, is the Carrington effect, which was September 1859, as it says up there. The only thing that mankind had going then was the telegraph network, which of course is wires on poles and men tapping out Morse code like in the Wild West. But it severely disrupted the telegraph network. Things caught fire. Telegraph operators received electric shocks and couldn't touch their equipment. There was even some reports of equipment being disconnected from the lines and turned off, and it carried on working. Strange things took place. But fortunately, they didn't have much technology in those days, so that was all that happened. August 1972, AT&T got clobbered. Long distance phone communication got belted by the results of a solar flare. Caused them to redesign their systems because they thought, oh, this isn't good. March 1989, a major power blackout in Canada left 6 million people without electricity for 9 hours because equipment on the power grid got overloaded by the results of a solar flare. And interestingly, I've underlined that for you, NASA said this solar flare was nowhere near the same scale as the Carrington event. Imagine today with GPS, airliners flying above, the internet and all the technology that we depend on so much. They're worried. If we get another Carrington level event, it's going to knock us for 6. It's going to take possibly weeks to recover from that. And some of you who work in IT will be repairing things. So yeah, to be worried about. So there's the first thing. We've got the solar flux index. We've got the sunspot number linked to it. We've got geomagnetic storms caused by solar flares and CMEs. So we're building up the pieces here, and I'm going to tell you how they all relate and how to use them in a minute. The last one I want to tell you about is the planetary K index. It's nothing to do with special K. Basically, all this is a number that they generated to show how disturbed the Earth's geomagnetic environment is. So if you get a CME, you get a solar flare, you get a geomagnetic storm, the K index will be high. This is a graph of what the K index was like during the big aurora that we saw. The KP, the planetary K index, was up to like 8, which is ridiculous. It's never usually that high. It's normally down here. Look at that. Sometimes it's 0 when everything's really quiet. But when the magnetic environment gets disturbed, the ionosphere gets a good pounding, you can see the KP index go way up. When you see that go way up, it means that your HF communications, all bets are off. It might work, it might not, it probably won't. So when you see a high KP, know that you're probably not going to get much DX. But again, you can track the KP. You've got apps and things. You can actually have a look. There's another one you might see called the A index. It's not as useful because that's just the KP averaged. So I don't find that as useful. I want to know what's happening now. So I look at this one. How to read the KP index? Well, there you go. Tells you here. If it's green, it's very low. No effect on devices or people. 0 to 4. Calm or small disturbances. The ionosphere is behaving itself. You're probably going to be able to get on and work some Italians. As it gets worse and worse, look. KP index G4 level, geomagnetic storm. Widespread problems with power grid voltages. Satellite navigation may worsen for several hours. LF radio navigation may be disrupted, so not even are the higher bands going to get knocked out, even the lower bands are going to get knocked out. The stuff that ships use to navigate and things are going to be dead for a while. You can get all kinds of problems, and the higher it goes, the worse the effects basically on our hobby. So what have we got? Here's the ones we talked about. The sunspot number and the solar flux, remember that. The planetary K index shows us what's happened in terms of have there been any disturbances because of solar flares. We can get alerts for those. How can we interpret them? How can we figure out what this means given the numbers? And where do we find the numbers as well? That's a good question. Well, here's the first one. The solar flux. As we said, the more solar flux you've got, the better the ionosphere is going to be working, basically. So, solar flux that was low, 50, 100, that kind of level. Your MUF is going to be low. HF communications in general are going to be poor or okay-ish. The higher the solar flux goes, it's going to be good. Over 200, hey, time to log on. Time to turn the rig on. Yeah. 300, brilliant. So the higher it is, sufficient ionisation in the atmosphere to support long-distance communications at higher than normal frequencies. So if you get a really high solar flux level and it stays there or it's bobbing about up there, it might be time to have a try on 6 meters or even 4 meters. You might start getting those producing ridiculous contacts. So here's another good idea. The K index. Well, of course, this measures disturbance, so we want it as low as possible. Yeah? The lower the K index, the better it is for radio in general. Putting those two together, as we've just been told, what we're looking for is a high solar flux that stays high for a couple of days, because it's no good like if you just had some huge geomagnetic storm and then you see the solar flux go up. Oh, brilliant, I'm going on, but it probably won't work. You know, give the ionosphere time to recover and recharge and get its energy back. So you want the solar flux high, preferably for a few consecutive days, and at the same time, you want the K index as low as you can. When you see the solar flux high and the K index low, get ready, you're probably going to work some good stuff. In between there, you can kind of judge for yourself where the conditions are going to be. So I've got some resources to show you now, where you can get these numbers from and what you can do with them. So they're the ones I'm going to cover, and I'm going to jump off this PowerPoint now and go down all those in sequence and just show you what we've got. So I'm going to sit down here so I can work this properly. So we get out of that, we'll get rid of that. Oh, I don't want to save it. Go away, get off. Why does Windows always do this to you? Right, so here's the first one. It works. Solar Ham is a pretty good place to look. As you can see there, you get an instant thing of the space weather. You get pictures of the sun. You can see the sunspots. Up there on the top line, see SFI is currently 239. There's your solar flux number straight away. top of the page. You don't even have to scroll for it. Sunspot number is next to it, SSN 213. The area business is talking about where the sunspots are and how closely grouped they are. All of these sites that I'm going to show you have a nice, this one especially, see it says Help Centre and FAQ. If you want to know more about all this stuff, just get on that site, click on that button. There's reams of information explaining all these different things in much more detail than I've given you tonight. But there's lots of stuff on there you can get. For instance, there you go, solar flare detection. You can see in as near real time as you can get what the satellites that NASA have got out there are picking up. Because that's how they know about solar flares in advance. They've got satellites at the Lagrange points, half like between the Earth and the Sun. So the first thing that's going to get clobbered is a satellite. And NASA's going to see the figures coming in from that and go, uh-oh, something's coming. And that's how they generate these.
Does that include all satellites, include ours?
How do you mean?
Well, if the sunspot affects the actual satellite, well, what does that mean that amateur satellites are using it, not them?
Well, it could do, yeah.
Will they recover from it, Alan?
Usually they do. I mean, they look at this stuff because people who fly satellites understand the risks and they want this information and they know how to mitigate it because they know it's coming. On the left there, you've got a 3-day geomagnetic forecast, so it's going to give you an idea of what's going to be going on. The number in the green box there is the planetary K index. So G0, G0, G0 for the next 3 days. They're not expecting anything particularly bad. And there's lots more stuff on there that you can have a look at. I won't go through it all tonight. I'm just showing you that this is there and you can have a look at it. The next one I want to show you is, of course, where all the figures actually come from. Which, if I can get this link to actually work here, come on, do it yourself. There we go, the National Oceanic and Atmospheric Administration, the Americans, of course. You can get all the figures on there, and basically all the figures these other sites use, they're nicking from NOAA anyway. It's not quite as easy to interpret. But what you do get is some good stuff here, look. R, S and G. If you look at the help thing for that, the R one is showing you how affected radio communications are going to be by what's going on. So we've got an R1 there, which means minor effects on radio. The latest observation is no effects, and they've got a prediction there going ahead. There's all sorts of other stuff you can find, just all the different things. Click on all of these, it takes you into a page. Estimated planetary K index shows you what's coming up and what they think is going to be coming up. One thing I do want to show you under here is if you go under subscribe and you click on this subscribe now, you can go in, register your email address. It's completely free and you get email alerts for all these different things. I mean, down here you've got all this stuff that they can provide you real-time alerts on. X-ray flux alerts, event summaries, radio bursts, geomagnetic warnings, alerts, watches, proton flux, forecasts and summaries. These are quite good. And advisories as well. The Space Weather Outlook is another good one. I've registered quite a number of these. So what happens is in real time, I get emails from NOAA telling me, hey, there's just been an X-ray burst, there's probably a solar flare incoming, expect it at this level, expect a geomagnetic storm is now in progress, and you get it almost in real time. So if you're wondering what's happening on the bands and why the bands are so rubbish, you've got the information there in your email inbox and you can tell what the experts are seeing and you can understand what's happening and why. So that's really worth doing. If you're interested in this stuff, sign up for some of them alerts and you'll get a lot of stuff from there. Here's another one. This one's called HF Propagation. If you've seen the websites where people put a banner on there and you get the predictions of what the conditions are going to be like, you see these ones here, you've seen that, with the day and night conditions, good, poor, etc. What this guy's site is doing is he's taking all those figures from NOAA, he's generating a prediction, and it's producing like an HTML banner thing in various forms that you can attach to a website, you can publish, you can use the data, you can do whatever you want. So that's another good place, and he also does some other good stuff on there where you can go in, and he provides a lot of information at the top where you can understand this stuff, and you can find more help about what it all means. So there's another one for you to think about. Of course, those of you who built a hand clock, you can actually get this information displayed on your hand clock. You can get the planetary K-index, you can get the solar flux, you can get the sunspot numbers, you can get the predictions of what's going on. You can get a graph that shows you the maximum usable frequency at any point on Earth. Because remember, Earth has got a dark side and a light side. Where the sun is shining, there's more energy. So the MUF is going to change. And that's why you can sometimes work really interesting stuff along the grey line, where the atmosphere is changing, the layers are moving. Strange things can happen, and it can work very well. So hand clock, if you've got hand clock, then explore those figures that you can actually get and put in those panes, and you'll find out you can get all this data that I'm talking about here and more in hand clock and have it on your telly to impress people who come into your shack. And you can actually explain to them what it means as well. A couple of Android alerts, apps rather. There's an Android app called Space Weather Live. You can sort of get an idea in these screens here of what it shows you. Get on here. So on the first page of it, you get the KP index straight away on a nice graph. You can see what's happening with the KP. You can then go into other stuff, current warnings and alerts, what's happening right now. Sunspots, predictions of the KP index, where the auroras are, solar wind, you can get the SFI figures and stuff like that, and more stuff as well. Another good thing about, can't remember whether it's this one or the other one, I think it's the other one, I'm not quite certain, but there's one of these two apps I'm going to show you where you can also go into behind it and you can sign up for more alerts. And the thing about these alerts is they're more general on the app, so they give you a bit more of a generic idea rather than just like X-ray burst exceeded this level and you've got to figure out what that means. The alerts are more generic, basic. Right? I can't even say the word. So it'll basically say things like, you know, HF communication disruption in progress or something. So it's another good thing to have. This is a good one. There's also another good one here, which is the HF propagation app. And again, this is it's the same sort of thing. It's giving you basically what you saw on those banners there, but as you scroll down, as you go through the pages, you can get all the figures behind it, and you can also, as I said, one of these two apps, I can't remember which one it is, but one of them you can go into the sections behind it, the menus, sign up for those push alerts, and they just pop up on your phone. So between those and the emails, I get like complete warning of everything that's happening. I know what's happening with the ionosphere, I know why, I know when there's a solar flare, I know when conditions are likely to be good or bad, and it's just really, I find it really informative. And as I say, you can look at those numbers, you can interpret the numbers now, you can understand what they mean, and hopefully it's made things a little clearer. But all those resources are, Jim's put them on the website, so there's links to them. And there's also a really good YouTube video by an Australian guy. I've put a link to that up there as well. If you forget everything when you've gone home and you go, oh, it was interesting, but I can't remember any of it, just go look on that video on YouTube when you've got a cup of coffee, and he basically explains to you in less time, and more interestingly, with nice graphics and background music, what I've told you. So there you go, solar weather and its effects on propagation, how you could know what the bands are doing. So you never have to go, the bands are dead, I tell you, dead.
You've got to call CQ. You've got to call CQ as well. It's not you sitting there saying this bands are dead. Everybody's sitting there saying bands are dead and nobody shouts CQ.
Yeah.
Shout CQ, you might get a reply.
Yeah, just as an example of that, I was talking to Jess earlier on about that YL station. I sent the email around telling you that it was on. The band stunk on that day. I turned the radio on and I'm like, this is rubbish, I can't hear anything. But then in the middle of all this deadness were these people on this station. The reason that they were on was they'd gone to this massive DX contest station. I think it was Denmark or Finland. And when you go onto the
I
QRZ
got one
page,
in Switzerland on it.
yeah,
Right.
yeah. Well, did you go on the QRZ page and have a look at the station?
Yeah.
It was a monstrous array, wasn't it? I mean, they've got like a building in the middle and about 10 towers with all these massive beams on them and all these aerials. And they rented this thing for a week or something. So you can always work somebody. You know, just go on there and enjoy the hobby. And if all you can do is work some bloke down south on 80 metres, well, that's for today.
Yeah.
All else fails, go on 2 metres and you can